welcome everyone to basically the announcement of Tesla Energy. All right. So what I'm going to talk about tonight is about a fundamental transformation of how the world works, about how energy is delivered across the Earth. This is how it is today. It's pretty bad. So that sucks, exactly. I just want to be clear because sometimes some people are like confused about this. This is real. Okay. Okay. This is actually how most power in the world is generated with fossil fuels. And if you look at the curve, that's a famous curve, the Keeling curve, which shows the growth in CO2 concentration in the atmosphere. And every year it ratchets up. It gets higher and higher. And if we do nothing, that's where it's headed, to levels that we don't even see in the fossil record. So this is. Well, I think we collectively should do something about this, and not try to win the Darwin Award. So for us and a lot of other creatures too. So the way the grid works today is this: you've got coal, you've got natural gas, nuclear, hydro, and then wind and solar, but not enough wind and solar, obviously, in the presentation. That's an important point. So what we're here to talk about is the solution. I actually think it's really a fairly obvious solution. And the solution is in two parts. Part one, the sun. we have this handy fusion reactor in the sky called the sun. Okay? You don't have to do anything. It just works. Shows up every day and produces ridiculous amounts of power. Okay? Now, a lot of people aren't clear on how much surface area is needed to generate enough power to completely get the United States off of fossil fuels. I mean, most people have no idea. They think that it must be a huge amount of area, like maybe you need these satellites in space and like space solar power. If anyone should be in favor of space solar power, it should be me. But this is completely unnecessary because actually very little land is needed to get rid of all fossil fuel electricity generation in the United States. That blue square there is the land area that's needed to transition the United States to a zero carbon electricity situation. It's really not much, and most of that area is going to be in rooftops. So you won't need to disturb land. You won't need to find new areas. It's mostly just going to be on the roofs of existing homes and buildings. So I really think that image is an important one to bear in mind when people are thinking about solar power. Like, how much will it take? Is it going to take some enormous amount? No, it's just that blue square. Okay. Blue square. Now, the obvious problem with solar power is that the sun does not shine at night. So I think most people are aware of this. So this problem needs to be solved. We need to store the energy that is generated during the day so that you can use it at night. And also, even during the day, the energy generation varies. There's a lot more energy generated in the middle of the day than at dawn or dusk. So it's very important to smooth out that energy generation and retain enough so you can use it at night. Now, what you may not have noticed in that earlier, so that's sort of the grid typically in most countries. And then you'll notice something, which is that there's quite a big difference in peak to trough usage. So the peak usage is typically at least twice the trough usage. So please bear that in mind. I'm going to reference that again later in the presentation. That's an important